All right. Some have argued that throwing darts at stock pages to decide what companies to invest in could be a successful stock picking strategy. Suppose a researcher decides to test this theory and randomly chooses 50 companies to invest in. After a year, 26 of the companies were considered winners. That means they outperformed other companies in the same investment class. So that's more than 50%. To assess whether the dart picking strategy resulted in a majority of winners, the researcher tested H0, or the null hypothesis, P equals 0.5, which means randomly choosing 50-50, versus H1, P greater than 0.5, which means that actually throwing darts works, and obtained a p-value of 0.3886. Explain what this p-value means and write a conclusion for the researcher. Explaining p-values is the tricky part of this chapter. So I'm going to go back and look at it a little bit. We have our sampling distribution with our mu sub p hat here. And we are looking at that being 0.5 because 50% of the time you'll do better than this and 50% worse. We're going to look at our sample. Let's say it's here, and our p hat was 26 out of 50, which is going to be 0.52. So 26 divided by 50, I get 0.52, whereas p hat here, the mean was 0.5. So they did the test and got a p-value of 0.3886. So this is this shaded area here. This is the shaded area to the right of 0.52. And that's the same thing as the probability that we'd get a p-hat as big or bigger than 0.52. And that was equal to 0.3886. So this is the probability any random sample would be at least p hat equals 0.52, which is not very random. It happens more than a third of the time. So it's not a great proof that the proportion is greater than 0.5. So we're not going to. So if we look back here, it says about 39 in 100 samples. Remember, our probability is about 39%. Okay, so I'm going to write that again right here. We have our p-value is our probability, and that's 0.3886. So that means about 39 in 100 samples will give a sample proportion this high if the population really is 0.5. So it would be A. Okay. That p-value is the same thing as our probability. And remember in chapter 7 and 8, when we were looking at probabilities, we often took the probability and looked at how many samples, particularly in chapter 8. So this one is not right because it's looking at that it would be this high if the proportion was really greater than 0.5. We don't look at whether it's greater than 0.5. We look at if it's 0.5 because that's our null hypothesis. Does that help?
Yes.
Okay, so I'm going to go on to the second one.